Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Perkenalkan, nama saya Alif Akbar, NPM 223510900. Bella di sini saya akan menonton harapan perkuliahan, yaitu materi dari Bapak Rizky Fadila, yaitu menonton YouTube materi Rex Hooks Explained dari YouTube. Bella.
Going to be teaching you guys every single React hook. If you're familiar with my channel, I have a video already on this. It's actually my most successful video so far on my channel. And the reason why I wanted to remake this is because that video was made 3 years ago and I didn't even cover every single hook. And as of 2024, a lot of new hooks were introduced. Some hooks were removed and became completely deprecated. So I wanted to make a new video on this because it seemed like a lot of you guys really enjoyed my last one. My purpose of this video is very similar to my last one, where I don't intend you to watch the entire video at once, unless you actually want to learn all the hooks at once. But rather, use this video as more of a cheat sheet. If you ever want to refine your skills or learn one specific hook that you might need for a specific use case, check the video part for that hook in this video. I obviously put timestamps on this video so you can just move around and choose the specific hook that you want to learn. And also, I'm going to not only put all of the code for this video in the description, but also I'm going to write a step-by-step version of this tutorial where you guys can just go if you want to, if you prefer text-based form. It's going to be on my website, so go to the description. It's pedrotech.co if you're interested in that as well. But yeah, that's basically it. Before we get into the video, if you could leave a like and turn on for the count, and we have no functions to call when you click the button. Before we create any state, let's just do it how we would normally do with a normal variable, as if you were playing around with JavaScript. I'll create a constant over here. Actually, I'll create a normal variable that can be altered, and I'll say count is equal to 0, and then I'll pass this value over here by passing count. Perfect. You see, now we see the count being 0. On this button over here, I'll create a variable called increase count, and inside of here we're going to put some logic to increase the count and pass this increase count as the on click to this button. Perfect. Now, normally speaking, if I want to make this variable go up, right, this value go up by 1 each time, what I could technically do is do count plus or equals 1. But you'll see that this doesn't work. Now, it technically increases the value. If I were to console log over here the value of count, you'll see that in our console over here, it should technically, when I click the first time, show 1, then 2, then 3, then 4. So the variable count is indeed changing. But why aren't we seeing that change over here? Well, because if you were using vanilla JavaScript, what you would do now is you would directly grab whatever p tag is displaying this number and change its value to represent the variable. But we're not doing that. We're using React, where our DOM needs to be updated and re-rendered automatically depending how the state of our application is. So this is the idea of a state. A state, in its most simplest form, is just a variable that you can create and change its value. And when its value is changed, it will automatically trigger a re-render of your page to demonstrate the new value. So how do we create one? Well, the way you do it is like this. You say const and then set an open and closing square brackets. Then you set it equal to the useState hook. It should automatically import it from React. Then we open and close parentheses, and you'll see that most hooks will look a similar way. Now, what do you put over here? Well, you put the initial value of what you want your state to be. So in this case, count starts at 0, so we can put 0 over here. But this, you could also pass an empty string if your state represents a string, or even an object if that's the case as well. So we'll keep it as 0. And what do we put inside of here? Well, with the way that the useState hook is defined, and you can look at it if you want to, this should return back inside of here two things. The first is the value of your state, which is being called, you can call it whatever you want, let's call it count. And then it is a function that you can use to alter the state. So we're going to call this set count. Usually it has this notation with set in front and then usually the name of the state. But why do we need a function to change it? Because although this count variable is actually working similar to how it was before when we were using let, you'll see that altering the value of it by just increasing it like this doesn't work, because what you have to do is use this set count function and mutate the value inside of it. So we'll replace this over here and we'll open and close parentheses to call this set count function. Now what do I mean by mutating this value? Well, this function inside of here, it allows you to have a callback function inside of it. So a function that gives you access to the previous value of the state. So if count is 0 initially, the first time we call this prev value over here will be equal to 0. Now if we increase it by 1, the next time prev will be equal to 1. So what we return from this function is just the new value of our state with this alteration. So when we call increase count, we're altering our state in the correct way, and thus making React actually trigger a re-render because it is using the value of that state inside of this component. So you see now, if I keep clicking on this, it will keep increasing. Now, one cool thing that helps you understand more about the React lifecycle is looking at our old console log, this thing over here, right? If we go over here, we see that initially it's supposed to be 0, and we're not console logging initially. We only console log when we click increase count. So we are setting the count to be equal to 1 over here as the first touch of the button, and then we're console logging. So you should assume that when I click on this button, we should see 1 because it increases by 1 and then it shows 1. But you'll see that it's always lagged behind. It seems like it will always be 1 behind, even though it's after the set count. And the reason for that is because we're console logging before the page decides to re-render to show the new state value. And thus, the state actually only changes value after it's done running this increase count function. So keep that in mind. If you were to do set count over here twice, you'll see what will happen over here. It increases by 2 each time, but it also lags behind on both of them. See? So this is the most basic explanation of the useState hook. It will be the hook that we use for most of our other examples because it's basically the most simplest way of managing the state of replication in React. Now there's other examples that you can play around with, but I think that this should be enough to get you going to the next ones. Okay everyone, now let's go into the useEffect hook, which is the second most basic hook in React, in my opinion. This the set is toggle.
Stop! Do not try remote work unless you want to work from home, have a flexible working hours.
Toggle function, and on the child display I need to access the isToggle value. I need to pass that information as part of the props to the child, right? And imagine later on you might need this information, this state that exists on this parent, on child components inside of this two child components. So imagine I have another component over here that would need this toggle state. So I would have to pass it as prop as well. Now what this does is it opens your app for some organization issues. It introduces a topic that is known in React as prop jilling, which, for example, if I wanted this grandchild component to access the isToggle, but I didn't need this isToggle as part of the child display component, I wouldn't technically need to have it been passed as props to then pass to this. So it's prop drilling because you're drilling this prop through this component without it actually needing. Only the grandchild needs it. But because of how it is set up right now, you would have to do that. But it also can cause a lot of unnecessary re-renders of components. Because remember, if I'm passing something as prop, that means that every time that value is changed, it would trigger a re-render of this component. Meaning that even components that don't need to be re-rendered would be re-rendered just because they have that value as props. So how do you do this? How do you make it such that every single child of this context example component and even the childs of them have access to some sort of store that contains all the states from this component? Well, that's where the useContext hook comes in and the idea of managing your states through the context API. Now, before we write that, I want to point out, as a beginner, I recommend learning the context API for state management. But as you learn more and more about React, there are countless others libraries and solutions that you can implement. The most well-known ones are Redux, Zustand, React Query. There's a bunch of them. I have videos on a bunch of them as well if you want to check them out. But I definitely think learning the context API first is definitely the recommended. So how would we make it such that we don't have to pass this information as props? Well, the first thing we want to do is create what is known as a context. So I'm going to come over here and I'm going to call it const, and I'll call it the global state context. So I can call it whatever I want, right? Usually you call it depending on the context, but in this case over here, I want to make it such that all the components below this will have access to the state, so I want to make the state be global. So I'm going to call this create context by using the create context function from React. Now I won't pass anything over here. I can pass null if I want to, but this won't matter. What matters is that now I can use this context that I created and wrap it around this whole context example component that I have. I can pass in the global state context and press dot and make a provider out of it. Now a provider is like you're telling React which components you want to provide this global context too. So everything that exists inside of here will have access to the composition of states that you want to put inside of this context. Now, how do you put the states inside of here? Well, you pass a value to this provider. In our case over here, we only have one thing that we want to pass, which is both the isToggle value and the set isToggle function. Those are the only two things that we really need. So what I want to create here is an object that will pass these two informations. So I'll pass the isToggle state, right?
It's 9:15. How am I already underwater?
I'm in the same boat.
I'm in an actual boat.
I thought.
Right? You see the use state over here. How would I do something like this using the use reducer? Because remember what I just said, the use reducer is an alternative to the use state for more complex actions. That's why I added an extra action over here. Well, the most simplest way to do that is, first of all, we'll replace this use state with a use reducer. It will automatically import over here at the top, and we'll just place it over here. Now, the use reducer has the same format as a use state. It will return two things, but the two things that it returns is different from what we have over here, although it has the same logic behind it. Similar to how we grab the count over here, in the use reducer, we'll grab the state, and the state will represent the count when we create our reducer function. The set count over here, instead of let's call it set count, let's call it dispatch, because we want to follow the reducer pattern, and all of this are part of that pattern. Now, inside of our use reducer over here, we want to pass two things. We want to first pass a reducer function, which we will create in a second, and we also want to pass an initial value for our reducer. So similar to how we had before the count equal to 0 over here, we want to pass an initial value for this reducer. A reducer will be in the format of an object. So we'll pass an object with a count inside of it and an initial value of 0. Now, we want to create what is known as the reducer function, this thing over here. And we'll create it over here. So we'll say const reducer, and we'll pass in a function which will contain two things, a state and an action. Now, a state is just a placeholder value for the current state of your reducer. So in our case, we only have one piece of state in this reducer, which is our count. So if we want to access the current value of the count inside of this function, we can do state dot count at any time. Now, what is the action? Well, when you want to change this state in any part of it, you can dispatch actions, and those actions should be handled inside of this function. So for example, over here in our set count over here, instead of calling set count, we'll just dispatch an action and we'll give it a type. For example, in this case, it's the increment action because we're incrementing. So we're not actually handling the logic of increasing or decreasing or doing anything inside of this. We're going to do all of that inside of this reducer function. And if I want to subtract, I can do the exact same thing, but by calling a dispatch of type decrement. And I'll do the same thing for double over here. We'll call it double. Now, where will we handle this? Well, we'll handle it over here, and we'll probably use a switch to check all of the action types that exist. So it's actually action type. So we'll come over here. The current value of this input without using the useState hook. Because if you are familiar with states and inputs, you should know that you can indeed keep track of whatever is typed on an input by just changing a state to whatever the value of the input is. But if you want to use a useRef for this, you can do it like this. You can create a reference to this input, let's call it input ref, and then set it equal to the useRef hook. Now, this useRef hook will allow us to make a direct reference to an HTML element. In this case, it will be the input. So we can come over here and set this as the reference by passing in a ref property and then setting it equal to our input ref. Now, if I want, I can create here a button that, let's call it on click. I'll create a function that all it does is just console logs the current value of the input whenever we call this function. To do that, I'll create over here a button right next to this input. So we'll create the button and we'll call it console log. Sorry about that, console log, and we'll pass in this on click to this button. So on click equals to on click. Now obviously right now it doesn't matter what's typed over here, it will just console log value. But if I want to grab the current text written on the input, I can access all of the HTML properties of this element in the DOM by using the input ref dot current, and this dot current allows you to see all of that information from a ref. And the best part is that whenever you update a dot current of a ref, which by the way is literally what a ref is an object with a dot current inside of it, with a current property inside of it. Whenever you update this current, it won't cause a render, and we'll see that. But in this case, if I wanted to console log the value, I can just say input ref.
Jira is now for all teams. Jira is now for all teams. Even those cross-functional super teams that keep project managers up at night.
Ref.current.value, and you'll see that when I click console log now, it should actually put the information of this input. So it allows you to grab specific things from the DOM. Now, another thing that it helps you do, that is, people love to point this out, is focusing, right? You can call functions that are primitive to the HTML element. For example, if I want to focus on this input, whenever I click on this button, I can just say input ref. Actually, I will have to delete the console log. I can just say input ref dot current dot focus, and this is a function that exists in JavaScript. When I click on this, it should focus on this input, as you can see, and I can start typing. So this is the most common example of a useRef. But if you remember, I just said that if I change a value inside of this input ref, it won't trigger a re-render. For example, if I wanted to change the input ref dot current dot value, right, which we know represents what is currently typed on this input, and I want to change it to the word Pedro, you should see that when I click console log, which right now shouldn't even say that, but when I click this, it will change this thing to actually say Pedro. But if I were to create a use effect over here, right? Remember the use effect? If I were to create a use effect that updates, and it will trigger this function. We're not going to put a dependency list. It will trigger this function every time the page re-renders, and we console log the text page re-rendered. You should see that obviously it console logs initially, then I'll type this once, and I'll change it to Pedro. Even though the UI changed in a way, it didn't trigger a re-render. If you were using a state for this, it would definitely trigger one. So this is the main two use cases of a ref. Another use case is keeping count of the previous state of a state. So the previous value of a state. So I'm gonna show you guys what this means. Let's create a state here and use the example that we've been using throughout this whole tutorial. We'll create a count. So a counter state. We'll start at 0 and we'll call it count and set count. Now let's change this to have a p tag that will display that count, and we'll say just straight up count, and then we'll have this button which, like before, we'll just call a set count function to increase. So we'll say prev is equal to prev plus 1, and we'll change the name. I'll close this and we'll change the name of the button to increase or increment. Perfect. So we have this counter example. We've been dealing with this through this whole tutorial, right? Now, what if I want to constantly keep track of the previous value of the count? So whenever count is 11, I want to keep track of what the value of the state was before. Obviously, because of the nature of this specific example, meaning to get to 11, the previous value had to be 10, it's kind of redundant. But states that can have multiple variations of its values, this could be very useful. Now, if I wanted to do that, what I can do is, first of all, set up a use effect that will be called every time the count changes, and we can do that by passing the count to its dependency list. Then, what I can do is create a previous count ref. So I'll say const previous count is equal to use ref, and we'll set it initial state to 0 because that's the initial count. Now I want to display that p tag over here as well, and we'll actually put a label to this. We'll say previous count, and we'll put a count to this one. Nice. Now we'll pass in to this value the previous count dot current. Now you might think this is weird because previously the dot current value had stuff to it. It wasn't a number or a string, but now it is a number because we set it to be. We didn't pass this as a reference to a DOM element. We're using it as an actual variable. Now when I click increment, you'll see that the count goes up, but the previous count doesn't, because we're not doing anything with it. What we want to do is make it such that whenever the count changes, we want to set the previous count equal, previous count dot current equal to the current count. So you'll see that it will always be equal to the previous version of the count state. So it's a good way for you to remediate how your states are changing and understanding how your app is working without actually causing issues like re-rendering. The best analogy I've heard for the useRef hook is that it's like a sticky note that you can attach to a DOM element or a variable, and you can read and write it, but it doesn't really affect the rest of your component's behavior unless you explicitly use it. So it's one of the most important hooks in React, in my opinion, one of the most underused hooks as well, but at the same time, you start understanding it the more you run into situations in which you need to use it. Okay, everyone, now let's talk about the use imperative handle hook. It's probably the hook that you'll use the least by far out of all the hooks. If you watch my previous React hooks course, I also mentioned this, and I gave one use case for that, and I believe that's the only use case I ever ran into where I needed to do this, especially because the main pitfall of refs and the use imperative handle hook as a whole is that you shouldn't be overusing refs in your projects. So the use imperative handle hook is only used whenever you are using refs and in a specific use case to it. So it's the kind of thing where, to be honest, if you want to skip this part of the video, feel free to do so. I even want to go through it fast because I don't think it's actually explaining by typing everything will probably give a worse explanation. So I already built up an example over here of how the use imperative hook can work, and I also wrote some comments so that you guys who are just looking at the text can actually understand everything as well. So the use imperative handle hook works by basically allowing you to customize the ref you decide to expose to a parent component. And it's very useful when a parent component needs to interact with a child component and you want to control exactly what synchronously after all of the DOM mutations that occur, but before all of that UI is painted into the screen of the user. So this means that this use layout effect hook is very useful for tasks that you need to measure or manipulate the DOM immediately after changes, ensuring that the DOM is in its final state before you paint the screen. So in this example we have over here, we have a very simple box, which we basically just typed resize me. It's a box. I painted it blue. I'll actually paint the color of this black so you guys can see the text better. But it's a box that is just said resize me, right? Now, why does it say resize me? Because below the box it says that the width of the box is 154 pixels. So if I change this to 80% width, it should change to a different value. Actually, I'll make it 50. Yeah, I don't know why that happened, but yeah, it should show a different value, like 82 pixels, right? Now, why are we using a use layout effect here instead of a use effect? Because if you look at this, the use effect technically works, but if you notice in this case over here, for a brief second, it didn't actually re-render automatically. We're getting the information for the box width by accessing the DOM element, directly using a use ref for the box. So we create a use ref, we assign it to that div, and we grab the current width of that div from the DOM element. So we do that using a ref, and all of that happens before it actually paints to the screen. But a use effect is called after all of that is already in the screen. So technically, for a brief second, if we refresh this and it's rendering for the first time, if we're using a use effect, it wouldn't have the information accurately for the box width until this ran, and then it set the correct information. So this is all that the use layout effect does. It just runs before the use effect. It runs in that small gap between the DOM existing and having its changes and the UI being painted into the screen. Now, it is good, like I said, for doing stuff like getting sizes or positions for a DOM element, and it's good as well for synchronous DOM updates when you specifically need to update a DOM element and avoid flickering or incorrect measurements. So in this example, if we were using the use effect instead of the use layout effect, this would have to run twice because the page would have to render twice because the use effect would render first without this action, and then it would trigger the set box width because it would get the information, and then it would render again. It would cause a little flicker that we saw. We don't see it anymore because everything is very stable. But if I were to change this, maybe let's put it to 90 again. Yeah, we didn't see it, but imagine in a larger scale project, you should see it. And the use layout effect allows you to have access to this, and it doesn't require that much, but
What if you could think faster? You can with Brain HQ.
in the first time you type item, it does require because it's looking through everything, right? So this is the basic example of why you might want to use the use transition hook. I use it a good amount. It keeps interactions with the users pretty smooth. It avoids UI freezing during like expensive updates, and it overall just improves the user experience because it shows loading states when usually previously I couldn't show loading states, or at least I didn't used to, because I obviously use loading states when I'm fetching data from an API. But with something like this, where I'm filtering data and doing everything on my code, I don't really have alternatives other than this, or I didn't used to. So I do think it's great, especially for situations like filtering, which is the most common use case I've seen. Now, if you're a beginner and you're watching this, I would say that the easiest analogy to understand the use transition hook is that it allows you to put less attention to the important work, which is in this case filtering the items because it takes longer, and put immediate attention to an easier thing to just show to the user, so that users get immediately happy with what they're seeing. They're seeing something happening, they're seeing the loading screen, while the complex and hard thing is being done in the background. So I personally think it's especially useful for improving performance and improving user experience in large or complex apps. Now let's go over the use deferred value hook. This hook is extremely similar to the previous hook we just explained, the use transition hook, but it has some minor differences that completely change the use case. Is updated too frequently, like when you're typing on an input to try to search and filter for a list, and you're typing too fast, which makes the state update a lot, meaning that it might cause issues with the performance of how your states are, or how your components are updating. So the main characteristics of this hook is that start transition function. So this is one of the most useful ones, I think, from the new hooks that we have so far, together with the use transition hook. I think there are things that a lot of people probably didn't realize would really benefit them and their projects, and React is really handing down the whole part of improving performance, because that's definitely something that will help React in the long run. Now let's talk about the use sync external store hook that was recently introduced in React 18. Now, to explain this hook,
hi guys, so if you are from Indonesia and if you want to work
and the get snapshot. Since I'm not using server-side rendering for this, I'll remove that. But we'll create those and we'll import it on this file. So the first thing we want to have a store for something like this logic of fetching Pokemons is creating a state variable. So we'll create a state, and it will be an object, and we'll have one piece of information, one property called Pokemons, and it will be an array. And we'll call this the initial state. Then we'll have some listeners, which will also be a list because it will be the list of our subscribers. Then we're going to have a function over here that is going to fetch the data and update the state. So inside of here, we're going to create and export a fetch Pokemons function, which will be async. And we already have that logic, so I'll just paste it over here. I'll grab this over here, paste it. Now, one thing you might have noticed, oh, actually, I'll delete this. One thing you might have noticed is that we don't have a set Pokemon's state like we have over here. So instead of saying set Pokemon's, what we can do after we get the data is we can set the state variable that we have at the top equal to Pokemons, and then set the data dot results inside of here, because data dot results is how we get the information from the Pokemon API. And then we can use that listeners array to loop through each. There's a couple things and that differ between doing that and using the useSync external store. I think it mainly differs on purpose, performance, and reactivity. So talking about the purpose, they use sync external store, like I said. The purpose of it is just syncing React components with some sort of external store. Whilst they use context hook and creating a context, it's some components, maybe some global states like the theme of your website, or if the user is authenticated or not, maybe use a global context. But in this case over here, if you're syncing with global state libraries like Redux, or you're using external state sources, something like the sync external store might